You are welcome to Global Learner Solution YouTube channel. My name is Ija Ekbuku Joshua. Today we want to treat mathematics. And our topic today is trigonometric ratios. Trigonometric ratios. Under this, we are going to look at the right angle triangles. Under right angle triangles, we have three sides. If I have this as my theta, that is the angle. That means I have the sides A, B, and C. The side opposite the angle, I say opposite. The longest side, I can call it hypotenuse. While the base side to the angle, we call it adjacent. So let me take this as my small b, let me take this as my small c, and let me take this as my small a. Don't forget to subscribe to our channel. Like, recommend your friends. Let's go back to the board. Trigonometric ratios. Now, one of the ratios we are going to consider sine. If I take sine theta, what is sine theta? Sine is opposite all over hypotenuse. Don't forget we have what we call SOHCAHTOA. The S here, sine for sine, stand for sine. Meaning sine is what? Opposite all over hypotenuse. The C here stand for cos. Cos, short form of cosine. Meaning cos is what? Adjacent all over hypotenuse. The T here stands for tan, that is tangent, meaning opposite all over adjacent. So in the first ratio here, we have sine theta is equal to opposite all over hypotenuse. What is our opposite here? That is C all over B. Now the next one is cos theta. What is car? From here, we have what? Adjacent all over hypotenuse. Adjacent all over hypotenuse. That's what we have. What's our adjacent? A all over B. And then we have tan theta. What is our tan? What's our tan? Opposite all over adjacent. Opposite all over adjacent. And what's our opposite? We have C all over A. Apart from this, we still have other ratios. We have ratios like sec theta, that is secant theta. And what is secant theta? Secant theta is inverse of cos theta. That means if theta, cos theta, look at cos theta here is A over B. That means inverse of A over B is going to give us what? B over A. B over A, meaning these are B. Hypotenuse all over adjacent. Now we have cosec theta. What is cosec? Cosec is inverse of sine theta. And what is our sine? Sine is C over B. The inverse of C over B will give us B all over C. And then we have cot theta. That's cotangent of the angle, cot theta. And what is cot theta? Inverse of tan theta. And don't forget, what's our tan theta here? C over A. That means you are going to have A over C. Very, very important. So we have been able to look at this right angle triangle. I've told you the longest side, we call it hypotenuse. The side facing the angle, we call it opposite. While the one, okay, on the base with the angle, we call it adjacent. It's not a must that we should use theta. You can use beta, you can use alpha. It depends on the equation. It's not a must that opposite should be here, adjacent should be here. If the angle is shifted to this point theta here, it means this place will be the opposite. The side facing the angle is the opposite, while this one will now turn to adjacent. For the sake of what we have done so far, let's still maintain this place as angle. Now let's solve one or two problems. Consider this triangle. Let me have 5 here. I have 4. I have 3. And this is my theta. And now the question is, consider the right angle triangle above. Find number 1, sin theta. Number 2, cos theta. Number 3, tan theta. Number 4, sec theta. Number 5, cosec theta. And then number 6, cot theta. From what we have done so far, what is our sin theta? And then let me add theta. What is theta? Now sin theta is what? Opposite all over hypotenuse. What is our opposite? 4. Then our hypotenuse is what? 5. These are hypotenuse. These are adjacent. And these are opposite to that angle. So if you have to find sin theta is what? Opposite all over hypotenuse. So the answer is 4 all over 5. Very simple. Very, very simple. Very, very simple. Now, what is cos theta? Adjacent all over hypotenuse. So our cos is going to be 3 all over 5. What will be our tan? Opposite all over adjacent. What's our opposite? 4 all over 3. You can, if you like, you can reduce it to 1 and 1 over 3. What is our sec? Sec theta. Sec is what? Inverse of cos. You don't need to stress yourself. Just to take inverse of what? Cos. And what's our cos? 3 over 5. That means sec theta is going to give us what? 5 over 3. And then you can use that to mix fraction, which will give us 1 and 2 over 3. And what is our cosec? Our cosec is 1 all over sin theta. And what's our sin theta? 4 over 5. Meaning cosec theta is going to give us 5 over 4. Very simple. 1 and 1 over 4. And then what will be our cot? Cot theta. Our cot is what? 1 over tan. And what's our tan? 4 over 3. That means cot is going to give us what? 3 over 4. The question now is, what is the theta? What is the angle? You can use any of these to solve the angle, any of the ratios from the sine, from the cos, and from the tan. Now let's look at sine. Let's use sine. Okay, we are solving this particular last problem, theta. What's our theta? We have here that what? Sin theta equals to opposite all over hypotenuse. The opposite, we said that sine is what? 4 over 5. So how do you get your theta? That means if I have sin theta equals to 4 over 5, and 4 divided by 5, what does that give us? Can you guess? That will give us 0.8. So if I have sin theta is equal to 0.8, what is theta? Theta will now give us what? Sine inverse of 0.8. What does that give you? Okay. So when once you press that, your calculator can give you second function. You press second function, sine this, and then you get your answer. I think that is very simple. Very, very simple. Can you do that? Try and get that. All right, let me give the second question. If sin theta equals to 12 over 13, find A, cos theta. B, find tan theta. C, find sec theta. Now let's solve it. Solution. This is another very simple problem. Most of these questions, when you see them in your exams, you don't have to be afraid. It's very, very simple. That is why we are here for you. So that when you subscribe, you see a lot of things so that it can help you to pass your exam. Very, very simple. I promise you. When it comes to mathematics, it will be a walkover. Let's go back to this problem. Now, sin theta. One thing that should come to your mind, okay? Sin theta, please, we consider this. Maybe we can say what? At angle 90. That's with respect to 90 degrees. Sine, if I decide to take this as my theta, don't be confused. I told you that what? Here can be your theta, here can be your theta. In this kind of question, we have not been told where to put your theta. But let me still maintain this. Okay, so I can take this as my theta. Okay, now sine is what? Opposite all over hypotenuse. That means opposite is what? Opposite is the 12. Hypotenuse is what? Is the 13. So opposite, you just come to your triangle, 12. And then hypotenuse, which is what? Which is your 13. How do you get this? Okay, you can use what we call Pythagoras Theorem. Because here it's not given to you. Okay, so how do you get this? For you to get this problem, let me still label them. A, B, and C. How do I get BC? I can say that BC from Pythagoras Theorem, the longest side, AC, equals to what? Square root of what? AB square plus BC square. So if I am to get BC, I will now have that BC equals to square root of AC square minus AB square. Let me break it down again. From here, how did I get this? Watch. Let me remove this root. That means I can have what? AC square equals to AB square plus what? BC square. So if I'm to make this subject of formula, that means what? BC square. Look at it here. BC square. Let me also remove this. Okay, don't be confused. It's very simple. It's very, very simple. Okay, I have BC here. That means BC will stand alone here. This one will come to this side, and positive here. When it crosses the equal sign, it becomes what? Negative. That is why we are saying that what? BC square equals to what? AC minus the AB square. So for me to remove this, if I clean this square, I'll now introduce the square root, as if I'm taking square root of both sides. Okay, well, square root of the 2 there, power 2 will cancel out, while this one remains. So for this question, we now have, what's our AC? Our AC is going to give us what? 13 square, that's square root of 13 square minus square root of what? Square root of 12 square. Okay, let's continue. What is square of 13? That means at BC, square of 13 gives us what? 169. Then minus square of 12 is what? 144. I have this. That gives us what? 169 minus 144. What does that give you? Wow. I think that's very simple. That gives you 25. What is square root of 25? It is not 625. You are not multiplying. What you do there is just what? The square of it will give us what? 5. Therefore, our side BC is what? Is 5. Now, let's go back. With this what is the Pythagoras theorem. From here, I make this subject of formula, which will have what? BC square, okay, equals to AC square minus AB square. For me to remove the square, because we are not looking for BC square, we are looking for BC. We now take square root of both sides. So BC square, the square root of that square, what makes BC to remain what we are seeing now. But we take the square root of both of the other side of the equation. Now, if we recall our triangle, what do we have? Don't forget, this is our original triangle. I have here theta. I have here 12. I have here 13. These are A, these are B, these are C. What's our BC? What? 5. Our BC is 5. Now we have gotten all the sides of the triangle. Now let's solve this problem. Let's solve the problem very fast. Very fast. Very, very fast. Okay, the first one is what? We have to find cos theta. Can you remember what's our cos theta? What's our cos theta? Very good, very good, very good, very good. Car adjacent all over hypotenuse. What's our adjacent? 5. And then what's our hypotenuse? 13. 5 over 13. Very simple. And then what's our B? Tan theta. Tan theta, 12. Opposite all over adjacent. Opposite all over adjacent. That means what? We have opposite all over adjacent. What's our opposite? 12. All over adjacent is what? 5. You can decide to break it down. What does that give you? Can you change 12 over 5 to mixed fraction? Can you guess? Alright, I know, yes, that's wonderful. I trust you. So we now have what? 2 and 2 over 5. How did I get that? 5 times 2, 10. 10 plus 2, giving us what? 12 all over that 5. And the last one is what? Sec. Don't forget, what did I tell you? I said that sec is inverse of cos. That is what? Sec is equal to what? 1 all over cos theta. And fortunately enough, we have already calculated cos theta. That means our sec now, sec theta is going to give us what? 13 over 5. You can still turn that into a mixed fraction. That gives us what? 2. Okay, 5 goes into 13. How many times? 2 times. That's why we are keeping it here. And then what number will you add to 10 to give you 13? 3. That's our answer. See, it's very, very simple. So by next class, you are going to see simple ways how to solve this problem. Very, very simple. We'll go into the sine rule, the cosine rule, and the rest of them. Thank you. Like our page, subscribe. Thank you very much.